Good morning, everybody. Thank you all for joining us today for our introduction to the TotalArc BMS View. So really excited about this one. It's a new product for us. In a way, it's a spinoff of the existing BMS. But we have the great Jim Benzo here to dive into the design. He was an integral part of getting this new BMS out into the market, and we're excited to tell you more about it and answer plenty of questions. So we'll give you all an opportunity. There's the chat box, so feel free to ask questions throughout the presentation, and we'll also give you an opportunity at the end to address those. So with that, we'll go ahead and get started. So for those of you that aren't familiar with us, I'll just do a quick overview about OGI. So we've been in business for 32 years so far, so a long history in the heater industry. Everything we do, from the design, manufacturing, is all done at our single location in Sand Springs, Oklahoma, which is a suburb of Tulsa. We are a women-owned business, so very proud to be included in the WBNC organization. And we actually had a really exciting 2022 and 2023. So in 2022, we were the Tulsa Regional Chamber Manufacturer of the Year. And then in 2023, we were awarded the Small Business Administration's Manufacturer of the Year for all of Oklahoma, which we're really proud of the team to get that recognition. Excuse me. It's still early, right? So, and then 2023, top places to work, and we're also the Avita Diversity Champion. So just quickly, overview of our products. So Terry, Quickwater, OGI Process Controls are our main three product lines. Obviously today we're going to be focusing on the OGI Process Control side, which is the TotalArc family, which is also incorporated into the Terry. So that's why we've got this fancy Venn diagram here that shows kind of everywhere we're involved. So we'll be focusing in this area right here. So the manufacturing industries, pipeline, utilities, natural gas, RNG, government agencies are all the areas that the BMS is available to be provided for. So so that's just a little bit about us. And with that, I'm going to go ahead and pass things over to Jim and let him take the presentation from here.
All right, let me get control here. Thank you so much, everyone, for being a part of this webinar. We think what you're going to see here is something that is exciting for the things that we have, is just another transition, another option that's available as far as burner management's concerned for us. In this case, what we'd like to do is kind of provide you a preview of the future of burner management with regard to the TotalArc BMS system. The TotalArc BMS View follows the same design principles as the previous TotalArc system, in that it's modular system that's pre-assembled, that allows for a very smooth installation. The TotalArc BMS View offers the next level of control and monitoring for our traditional BMS systems, providing improved heater operation, real-time indication and set point adjustment of the heater and bath and process temperatures are provided. The TotalArc BMS View displays this information on a 4-inch color display and a series of screens that are clearly displayed, displaying the information that is presented. The display configuration is simple and clear to understand, locating all the information necessary for on a reduced number of screens that the operator will have access to. And the operator can change set points easily through operator interface provided, improving the temperature control. Real-time BMS operating sequence for the pilot, the main burner, and purging and proving periods are all provided as well. So you can see in the transition or what's occurring while the BMS is in the process of either lighting the pilot or the main burner, or just during burner operation or just waiting in standby, waiting for a call for heat. Here through the BMS status display, the operator can view and confirm BMS steps and operating sequences. We also provide time and date stamping of alarm messages for connected heater safeties and BMS alarm conditions. Here, the operator interface provides alarm summary and history displays listing the alarm conditions in the sequence that they occur, providing a better understanding of the root cause of the alarm condition. As with other TotalArc products, there are 3 versions of the TotalArc Relighter to fit the customer's power requirements. Still offering an AC powered option, just requiring 120 volts be provided to the BMS system from the facility power distribution system. And this option includes an onboard battery charger for charged by the AC power. We also offer this in a DC powered option with requiring 12 to 24 volt DC power from the facility. And in this case, a backup battery or backup power is provided by the customer's power source or UPS system. A 12 volt DC power with solar backup is coming soon. It's in progress. We're evaluating that process, but that's coming fairly quickly. Again, this is, as in the past, has a 12 volt DC battery mounted in the TotalArc enclosure, and the battery is charged by the provided solar panel and internal solar chargers. Comparing the features of the TotalArc BMS View to the standard BMS, we find that both as we discussed earlier, utilize the proven TotalArc relighter flame monitoring and relighter technology. Both use electronic temperature control, but the added features of the BMS include real-time temperature indication of the battery, of the bath and the process that's connected to the BMS, and also allows for local temperature set point adjustment without special interfaces. Let's take a closer look at these features within the TotalArc BMS View. Here, the heater status display provides heater operating information and would be considered the home display of the BMS View. Data that's available is the pilot and burner on-off status, the real-time bath and process temperatures, and the active bath and process temperature set points. The bath and process temperature set points will be relative to whether you're in local or remote mode, and to be entered on the local controls to be entered on the local remote control screen that we're going to cover here in a minute. When in local control mode, the displayed set points are those adjusted by that local or on the local control screen. When in remote, these set points displayed are those that are received from the remote control interface defined in another screen within the BMS. This display also provides the active BMS control mode, as you can see here, as well as the remote control enable, indicating that the remote control has been released to to allowing the BMS to start the pilot and the main burner. Here's the local control control display, and this display is a password protected display that allows the heater to operator to adjust the local bath and process temperature set points and place the BMS into local or remote mode. In local control mode, local control mode will provide the BMS operator local control mode will provide BMS provide BMS operations based on local safety and control inputs, and the temperature control set points are entered are entered above in those two blue boxes. All during local mode, what's important here is that the remote control inputs will be disabled, but the local the remote control outputs will remain active if they've been selected to operate. In remote mode, this will allow the remote monitoring and control of the BMS per the remote interface type defined on the system configuration screen. So these remote controls will work in conjunction with the local BMS and heater safeties and control inputs. So essentially, though you are in remote mode, the local safeties and the local BMS controls will still be available and active to protect the heater and the BMS system. Additional features of the traditional BMS and BMS View include they both utilize a hardwired daisy chain heater safety string input to monitor the heater safeties. Both BMS systems provide a BMS lockout indication through a panel-mounted indicator light. So again, the indicator light will flash on either one of these, the BMS or the BMS View, if you have a lockout condition. But the major difference in the BMS is that it provides individual heater safety status and alarm indication. So you're able to actually see when an alarm occurs. So one of the advanced features of the BMS View display package includes the alarm summary display. This screen displays alarm messages chronologically with the most recent alarm condition at the top of the list. The alarm messages will be displayed in 3 conditions, either an active ACT alarm condition displayed in red and date and time stamped, or an ACK, an alarm acknowledge condition displayed in blue, which again will be date and time stamped, or an RTN, a return condition, which identifies an alarm state that has changed or returned back to its normal state. At that time, again, it will be date and time stamped. What's important here is that as these conditions change, as these alarm events change in status, the 3 alpha character status message will change, and the date and timestamp as well as the color will change, but the alarm message will still be only a single message. At any time, these alarm messages can be cleared by the heater operator, and either individually or the complete list. Now, historical alarms are summarized on the alarm history display. Here, the alarm messages are color-coded just as they were on the alarm summary screen, with red indicating active and blue indicating acknowledged and green indicating that a condition is returned to normal. But the benefit here is that all alarm events will be listed, as well as any changes to that alarm event from one alarm status to the next. Each one of those events will be listed as they occur individually, where you have one alarm for the active, another alarm listed for the acknowledge, and another alarm listed for the return. This will allow the heater operator to the ability to see trends in the alarm activity and identify reoccurring alarms. On top of that, they're also able to see if an alarm status has returned and when it returned to normal. Here we have the heater safety status display. Here, what this does is this shows the state, the individual state of each of the alarms that occur that are assigned to this. The number of these this heater, the number of safety displays displayed is relative to the size and the complexity of the heater that's being monitored. Here, the light conditions are obviously green for okay and red for an alarm. For a standard heater, a typical standard heater of less than 2.5 million BTUs, you're going to see a bath level and a high bath temperature, which are the most common safety shutdowns associated outside of the BMS. Those will be displayed, and the condition will be green if it's good and red if it's faulted. For a standard heater with a higher burner input greater than 2.5 million, additional shutdown conditions include the high stack temperature and the low and high gas pressure alarms, which again are common based on CST-1 to identify a potential problem with the heater, with the burner gas train. Something important to note is that, as I mentioned earlier, that all of these alarm conditions are still being wired in series with the within the BMS in a hardwired as a single input into the BMS. But each of these alarm conditions are individually being monitored, so that if any one of these occurs, the operator will know the condition or the status that has actually taken the heater down. As an alternative or an optional feature, the high process temperature shutdown is also an option that can be added and is commonly added when talking about NFPA 87 applications. Some additional, comparing additional features of the BMS system, both BMS systems include that hardwired BMS trouble contact. This contact is always available when the remote monitoring and control is enabled or disabled. So again, this is an output feature that we talked about that would remain active no matter what mode of operation you're in. The BMS View provides added hardware remote monitoring and control based on the remote burner enable and remote interface type selected, shown here. Now, this is a password protected screen. So once set up, it would be something that just the average operator wouldn't have access to unless a client gave them that access. When the dry contact is selected as the remote mode of operation for the enable feature, one burner enable input controlled by the remote and dry contact input from the client's local control system is enabled. So essentially you have one remote input that's hardwired that can come in and actually turn on and turn off the burner. When the 4 to 20 is selected, selection is made on the remote interface type. 2 retransmit features are enabled for the output that would be used to maybe communicate the heater bath and natural gas process temperatures. And the remote set point, there's 2 remote set points that are enabled, both 4 to 20, one for each the bath and the natural gas process temperature being controlled by the BMS. Again, these remote control and monitoring points will communicate with the client's local control system to coordinate heater operation with the station operation. So that way the heater is in tune with what the client is requesting. As a reminder, these customer control inputs, control points will work in conjunction with the local BMS heater safety and control inputs to enable and disable the operation of the pilot and the burner. So just because you've enabled something remotely, the BMS system is still actively taking care of the heater and itself based on what it sees locally for those safety features. The BMS system also provides a Modbus communication option. Again, The type of remote monitoring and control is based on the remote burner enable and the remote interface type selected, so that when the Modbus is selected, selection is made on the remote BMS. You have one burner enable input that will be available for to enable the burner and the pilot to operate when there's a request. Operation will be pending the local BMS safety and temperature controls. When the BMS is selected in the remote interface type, you have 4 retransmit and 4 set point options that are available. And again, this will be communicated and coordinated with the customer's local control system. When selecting the Modbus option for communication, the heater must select the type of Modbus signal that will be used. In this case, currently the Modbus RTU type is available, but the TCP will be available in future generations. Excuse me. Data exchange with the customer remote control system includes, as we talked about, writing bath and process temperatures, reading real-time bath and process temperatures, and then writing discrete pilot and main burner run and run inputs to the BMS. So we have those features available more, I guess, seamlessly through a Modbus communication. Now that we've talked about the features of the BMS, let's talk a little bit about the operations of the system. In this case, the BMS operation features two pilot and main burner control configurations, either intermittent pilot or continuous pilot with thermostatic control. This pilot operation will be selectable through the heater's control configuration screen. For intermittent pilot, again, just a reminder of what that entails. In this case, the pilot operates with the main burner's call for heat. So the pilot literally is shut off when the call for heat is shut off to run the main burner. And then when there's a call for heat of any type, the pilot will light and then the main burner will light. So to review that, in this case, the first step is to have the safeties satisfied. The heater safeties are satisfied and they're okay. And then in this case, we have a burner and a bath process temperature controller that are internal to the BMS. So once both of those are saying that they require a call for heat signal is generated, it lights the pilot. And then once the pilot is proven, the main burner will light. If the pilot is lost at any time or the call for heat is removed, then the pilot will be shut down and the main burner will be shut down and a purging sequence will occur. To lay this out in kind of a flow diagram, I guess, approach, again, what we're interested in is getting those heater safeties satisfied, and you can see that we're seeing a heater safety input occurring. Once the heater safety is satisfied, we're looking at, what is our call for heat, and once the call for heat is received, then the pilot will be lit. Once it's proven, the main burner will be lit, and then if that call for heat is removed, then the main burner and the pilot will be shut down simultaneously. If I look at a continuous pilot with thermostatic control, again, here to remind ourselves that the pilot will remain lit, remains lit, and will remain lit during the entire operation of the heater. In this case, just to remind ourselves that the advantage of that is that by having that pilot lit continuously, it eliminates the pre-purge requirement between the main burner and between main burner cycles. And in this case, the pilot will only cycle off when the bath temperature approaches its maximum normal set point. So that way, The pilot is always lit. It's always available. Your heater will be more responsive to conditions, but or a more responsive change in operating temperature. But the other advantage is that pilot will continue to operate until that maximum temperature is reached, and then the pilot will shut off. Again, these two sequences, or these two options for burner operation, are available in selection through the heater configuration screen. Again, just to kind of touch base, what we'll do is we'll take a look and make sure our heater safeties are satisfied. We'll look at our bath temperature controller. Once the bath temperature controller says it's okay and generates a call for heat, the pilot will be lit and proven. Once it's proven, it's waiting on the process temperature controller to generate a call for heat. When that call for heat is made, the burner will be lit. When it's lost, then the main burner only will shut down and the pilot will remain lit. If we lose the pilot, or we lose the call for heat from the bath temperature controller, then the pilot will be shut down. Again, to look at this in kind of a graphical format, first thing we want to do is make sure the continuous thermostatic pilot selection is made. In this case, when a heater safety is proven, then we're looking for a heat request that would occur at the pilot's level, or in this case, the bath temperature. At this point, the pilot will be lit and proven, and literally be standing by waiting for a main gas request. Once the main gas heat request is received, then the main burner will be lit and cycle on and off as necessary. I guess in summary, what we want to look at right now is just the features that you typically would receive with a BMS, with just a standard BMS, was, again, that utilized proven TotalArc pilot flame ignition and monitoring design principle. We're utilizing that same principle that has proven itself for many years to be reliable and dependable on monitoring that pilot flame and relighting as necessary. It still utilizes a single rod ignition and flame sensing, so you don't have multiple rods that are trying, or UV scanners or anything out there that you're trying to utilize. It has a simple, proven approach in that single rod ignition system. The added features that you have are configurable pilot operation that's at the touch of a button that's within the configuration of the BMS, real-time temperature indication and set point adjustment. So you have an improved control and controllability of the heater, and burner alarm messages, and remote control and monitoring. That's both available through hardwired or through Modbus. And because of the flexibility of the BMS, there are specialized control configurations that are also available. So if you have a special configuration or a special need within, like a fuel gas system for a turbine, or maybe a different setback system that you want to incorporate, that the BMS is configurable by just reaching out to OGI, and we can look through that. What's coming soon in the TotalArc BMS is the burner gas flow integration. We're looking to incorporate volumetric incrementing on the totalizer, I should say, on the actual screen. So you'll actually be able to see through a status screen, the fuel gas being utilized or used by the burner. Burner operation summaries, which include burner operating hours and cycle counts, as well as the pilot operating hours and cycle counts, and also the pilot pilot relight counter. So this gives you a good feel for the way that the heater's operating, and the any potential issues that could be associated with the burner or pilot operation. The TCP remote communication, as we discussed, for Modbus, that's coming soon, as well as we discussed the solar power with the 12-volt DC battery backup.
Well, I think that is all the questions we have. So really appreciate everyone's attendance today and participation. So we'll be posting this online, and then we'll also follow up with the PDF version so that you can review everything. So again, thank you everyone, and feel free to reach out to myself if you have any questions, and we're happy to answer those and help out however we can. So hope everyone has a good rest of your day and a good week. So we'll see you next time.